Welcome back. Now, in the previous case, we looked at the formation of an acetal. Essentially, you need two alcohol groups, all right? Now, if you keep that in mind and just look at this problem, there's multiple facets to this problem. I'm going to explain each and every one of it because it is such a unique problem. Okay. Now, if you remember in the previous problem, we used alcohols, but we used twice. The same thing was used twice. You could have chosen different alcohol, but we used twice of this. But what if you have actually the alcohol, both of them are part of a chain itself at either end of the chain? Well, this is no different than this. Instead of doing it twice, let's just do it all in one step and get it over with. Okay, let's not do this whole acetal process twice. Let's just do it all in once. Now, why do we need it? Now, typically, when you start with a ketone, okay, you see this compound's got two. And I selectively want to only reduce this reduction, okay? Which is, remember, lithium aluminum hydride. Basically, we're trying to reduce this double bond O, but we got one more. Now, lithium aluminum hydride reduces just about everything that comes in the way. So we have to protect the ketone, one of them, with the alcohol for time being, so we can reduce it and then release the lock again and then let it be the ketone itself. So essentially, I want my product to be tailored in such a way that I want to preserve this double bond O as double bond O in the end, but I want to reduce this. So what are we going to do? Well, I'm not going to go into mechanisms, but you got this, right? So let's do this. Make sure I don't draw too many carbons, because that's bad. All right, so you got these, you got the diol, right? Basically, this hydrogen along with this oxygen and this hydrogen comes off. What does that look like? When you have two hydrogens and an oxygen removed, well, that's water. So it's negative water. So what does that leave us with then? Well, basically, this double bond is now broken into two pieces. So what it's going to look like is, let me redraw everything minus this. So this double bond breaks like a V, connects itself to the two oxygen and then the remaining branch. So this is called what we saw earlier was a regular acetal. This is a cyclic acetal because, it presents a cycle. This is the ring. When you have a ring in chemistry, we call it a cycle, even though I don't know why that's a cycle. I mean, the wheels of a cycle is cycle, but. So now this group is locked. It can be reduced. So what happens when you add your lithium aluminum hydride and H3O? Well, basically I can tell you that you're going to add a OH and a hydrogen here. Okay, this bond breaks. Okay, this bond breaks. Now again, this is not, I'm not telling you to be robotized to, memorize this. Again, we've learned this. So basically double bond O becomes OH and a H, and then the other H goes with this oxygen. This part gets broken, and I always said when you have a C double bond O and you have lithium aluminum hydride, then you make COH. Every one of you did excellent on the exam. I can fondly recall that memory. So now we have selectively reduced. Well, keep in mind there's yeah, I think I'm right. Yeah, so this is a C. This carbon, there should be one more hydrogen, sorry. Okay, should be one more hydrogen. So because that would be carbon with only 3 bonds, so there should have been 2 more. So you have 2 hydrogens and an OH. Okay, All right, very good. So now we have to go back and unleash it. So that's where your H3O plus comes in. Well, basically we used this for this process, and this comes in second step. Basically, all you have to do is just add the double bond O again. So what it tells us is we can go from a double bond O to this craziness, and then we can come back to this. Okay, that's very, very important. So we can go back to ketone, to a cyclic acetal, and then with acid hydrolysis, which is what H3O plus means, we can regenerate the ketone. This is magnificent, isn't it? We have not disturbed the molecule in the end. We only took care of the portion we want to reduce. We just sealed the one end and then released the lock back again. So whenever a ketone goes through a cyclic acetal with acid hydrolysis like H3O plus, you can actually generate the ketone back. Okay, it's very important. Remember that. And that's the end of this video. And I think I got two more. So stay tuned.